Hi all, I'm Abhishek Kavinamali and this is a small demo of the sample project that I have done. I work at Telstra as a data scientist. My designation is data specialist and I predominantly work on natural language processing, anomaly detection and large language. And I use large language models as well. I use Azure ML as my cloud platform and I work with Azure OpenAI. So let me start. The problem statement is during work when work from home became a mandate due to the COVID pandemic. Um, many companies wanted to identify what kind of support they could give to their employees so that their productivity would increase, right? So if you see here, however, for the employees living together with families, including employees who have children, handling the boundaries between personal and professional life became a great challenge to understand the kind of support that can be provided to families of XYZ Corporation or XYX Corporation to enable a better work-life balance. A Pulse survey was then rolled out to determine family support, workload, supporting arrangements, and policies. So that's what this is about. So we need to predict what kind of support each employee needs. So this is the data dictionary. So we have different columns here and the explanation for each column. So employee ID is the unique identifier of an employee, and work from home setup available talks about whether he has a work from home setup at his home. Company types talks about the type of company, like for example service, private, etc. And gender is the employee's gender, so on and so forth. So I will give you 10 seconds time to have a look at this, post which I will continue. Now let's have a look at the actual data. So as you can see here, this is the actual data. So we have employee ID, we have the work from home setup available column, then we have company type, gender, etc. etc. So the column which I'm going to predict is the support column. So we have leaves, career, caregiving program, ergonomic, others. And so this is basically going to be a classification problem wherein this is a multi-class classification problem, and it comes under supervised machine learning. So we also have the review given by the employee about his company. So I'll be analyzing this as well, and I'll be trying to extract some stuff out of this so that it can help me in predicting the support. So yeah, let's get back to the code. So as you can see here, I've imported all the required libraries, and these are all the libraries that are used for both the LLM as well as the models that I'll be building, as well as for training. Transforming the data as well. I'm getting my data in a particular data frame. I'm checking the top 5 rows, and then I'm creating a copy of this data frame because I want to have a pure data which is unaltered, so that I can fall back to it if I made a mistake in transformation. So the code that you see is written is just written normally. I've not followed the object-oriented programming style because it's just a first cut or first prototype that I'm building, and I will improve it later. And I just wanted to get out a sample project to show you all. So I didn't have much time to make it much better, but there are a lot of things that I can improve here. And with respect to the optimization, the coding standards, as well as the model performance, everything. So there are a lot of things that I can improve, but this is something that I've done to better my knowledge and learn along with what I'm trying. So this is just a first cut. So yeah, if I've made any mistake, please forgive me and let me know about it as well, so that I can improve myself and make myself better. So first thing that I did was go extensively through the data, and I got to know that the column learning new thing has only one value, which is yes. So I'll be dropping it later, and there are 18,000 rows. I have verified that as well. So I'll talk about that piece later. So I've created a system prompt here. So prompt basically I've created it to give a persona to my LLM. And then I've created an example prompt which talks about the task it has to do as well as a few examples so that it can understand what it has to do. So I've given three reviews and I've also given the type of output it should give out. So I want a JSON output with the sentiment. So I've just told it to classify the reviews with regards to positive, neutral, or negative. And I have also said that the reviews can be in English or some other language. You need to translate it and then get sentiment. Now you'll be thinking, Abhishek, why have you used LLM to do this? You can do it the traditional approach also, right? Yes, we can. But here, if I have to do a traditional approach, then there are instances wherein the review is not in English, so I need to translate that using natural language processing techniques and then extract sentiment, which is going to take quite a lot of time, and the time is something that I don't have at my hand right now because of many other personal reasons. So I have used large language model, and apart from that, there's one very big advantage in large language model. I don't have to do data cleaning with regards to text data. I can directly send it, so I don't have to do some lemmatization, removing special characters, stop words, etc. It does not have to be done, and it will only translate on its own and it will only extract sentiment. So it is pretty convenient. Apart from the fact that it takes a lot of time to extract the sentiments. That's it. So I did say that I have less time, but I have less time to work. But I can keep this under execution and move away somewhere else, so that and focus on something else. So to keep on executing on its own, right? So yeah. So in that manner, I don't have to worry too much about all the other micro stuff. I can just go ahead and extract it using LLM. So that's what I've done. So this is how my actual prompt is. And to get the LLM, I went and downloaded a GitHub repo called Olama and downloaded Mistral from there. And here I'm testing Mistral. So I've tested it for one particular record, post which I sent all the records to my large language model and extracted a sentiment. So the following code that you see here has all of this. So sometimes while extracting, right, it adds unnecessary textual information. So in my case, it added this number for some reason, number and the colon. So I'm removing that here and then extracting it into a JSON object and then putting it out into a list. Now, an LLM performance depends on many factors. So it also depends on my prompt. So the better my prompt, the better result it has, and some models are better than the others as well. So I just tested it in Mistral. I didn't test it with other models that I could have checked. I mean, if I had done that, I would have had better results as well. Who knows? But here now, what has happened is instead of neutral, it has given mixed, all in caps, then there's M in caps and all I exit in small. Then there's something called neutrality. I have no idea what that means. And then there's none. There's neutral. So all of these have changed it to neutral itself. And then I've created a new column called sentiment towards company, and I've added it here. Post which I'm dropping the columns that I do not need, which is employee ID, review component, learning new thing. Learning new thing I've already spoken about, that's completely redundant, and employee ID is unique for each. So I cannot do much over there because it's a unique ID, right? Nothing you can do, nothing the model can learn from it. And review of the company, I could have extracted the key issues also, but again I had time constraints, so I've extracted only some sentiment. I could have done few more stuff with the review company reviews, but right now I do not need it, so I've dropped it. So this is how my actual data frame looks. Now I will be doing exploratory data analysis. I'm trying to understand the structure of data, the data types of different columns, if there are any type changes required or type conversion required or no. But as you see, this, as I've seen here, that's it's not required, so I haven't done, and I am checking the 5 point summary, the mean, the standard deviation, etc., so that I can understand how the data is distributed, and also the data distribution for categorical columns like the count and then unique values in it, etc. And the most important thing is checking out null values. Now, I've used df.isnull.sum. It gives the count of null values, and if I divide it with the total row count, it'll give me the percentage of null values. So, is this enough? No, it's not. So, it does not always mean having null null or np.nan as a null value. So, if we go back to the data, even these are null values, right? These symbols, it does not have any meaning to them. So we'll have to impute this. So how do we impute this? So that's what I will be doing later down the code. So let's get back to the code. So let's go move ahead and just see what I'm doing here. So wherever this symbol is there, I'm replacing it with no children. Basically it means that, right, that they do not have any children. That's why it's empty. It's there's no numerical value between the square brackets. So I've replaced that. And if you see the data here, this is the column name is children age. So it means this particular employee has one child who is 10 years old. This particular employee has two children, one who is 4 years old and another is 0 years old. 0 years old might mean few months old, so basically a newborn. Similarly, there are employees with three children also if you look at the data. So that's what I'm extracting here. I'm extracting the value inside the square bracket in this piece of code, and then I'm counting the different children that's available, and I've created a column called number of children, and I've added it in my data frame. Now, since I've derived stuff from this column, I do not need this because at the end of the day, children's age might contribute to the productivity of an employee, but I feel the number of children will contribute more because if you have more children, then more expenses to bear and more responsibility to have, which can in turn make you a bit lazy or can motivate you to work hard. Depends on the situation at home. We all work, right? So we know what happens. So that was my analogy, and I've dropped this particular column. So and then I checked the distribution of number of children. So the majority of the employees do not have a child. I mean, they are not a parent yet, but the maximum number of children an employee has is three. And yep, let's go ahead there. I've dropped it, and then I'm creating. Ignore this piece of code. This is not required. It was done by mistake. Yep, and then I've created a special data frame. I mean, it's not special data frame. I've created a data frame consisting of only the numerical column, and I'll be checking for outliers. So before checking for that, let me talk a bit about outliers. So what is it? So let's say you have a column called age, human's age, right? And you have values like -4, and then there's a value called 400. So this is not possible at the end of the day. So they are outliers. So they are basically out of the norm. That's what outlier means in layman's term. So anomaly, right? So to check the outliers, box plot is the best plot that you can use. So if you see here for this particular column and these available, these four dots are outliers. So what do I do to impute them? So let me talk about that technique. Here, if you see the box plot, this is the 25th percentile, this is the 50th percentile, and this is 75th percentile, meaning 25% of the data lies in this space, 50% in this, 75% in this space, right? So that's why I will using that. So my first quartile, which is having the 25 uh, percent, which is having the 25% of data, I'll be using that. And my third quartile, so I'll be subtracting third quartile minus my first quartile and get my interquartile range, and then I'll find the upper bound and lower bound. So this is the upper bound and this is the lower bound. So the formula is here, and afterwards, whatever is greater than upper bound will be replaced with upper bound, and whatever is lesser than lower bound will be replaced by lower bound. So that's what I have done in this entire code. Okay, and then I've plotted the graph once again, and as you see, all the outliers are gone. Then I have replaced it. I mean, I brought it back to the actual data frame, and then I will start my feature engineering process. In feature engineering basically means deriving different features from my current feature, from current list of features. So if you see here, completed task last week and assigned task last week, we can get the efficiency of an employer, right? So if you're assigned with 16 tasks and you've completed only 8 tasks, which means 50%, correct? So that's the efficiency. He is not performing that well then. So that's what I'm doing over here. I'm sorry, that's what I'm doing over here, and then I'm checking whether the employee is working overtime or undertime. So if you see assigned work hours, and hours worked last week. So if I'm assigned for, like, let's take per day instead of a week. Okay. Let's say I'm assigned to work for 5 hours and I'm working only for 3 hours. It means I'm not working for the full capacity, right? I'm working under time. And if I'm working more than 5 hours, then it's overtime. But does it mean that if I work overtime, I'm doing a good job? No. Does it mean that if I'm working for less time, I'm doing a bad job? No. It again depends on lot other factors. We'll talk about it. So, but this is what that particular thing does. And if you see the data here itself, you see this particular employee is working under time. His efficiency is 50%. His sentiment towards the company is negative. So, which basically means that he is not happy with his company. He's working for 50%. I mean, his efficiency is 50%. He's working under time. Why is that? Maybe because he's having health conditions, right? And maybe he has very. I mean, because of his being health, because of his health being pretty poor, he wants to take leaves, but he has less leaves, right? So there are multiple things you can infer like this, and then the support that company is giving is least. So if you see here now, this particular guy is working under 10, but does the same thing apply here? No, his efficiency is 90%, right? So I mean, he does not have much responsibility here. If you see the number of children is zero, but sentiment is neither good nor bad. He has no health condition, his partner is not working, he has flexible work hours, he's not used his insurance, he has a lot of leaves, three family members who need supporting, not a parent, does not have a partner, he's a bachelor or a spinster. I mean, it might be he or she, I don't know. I'm sorry for assuming that. But anyways, my point lies the same. So you can infer these things. So the same way, even the model will think. I mean, model will not think like how I'm thinking. It will basically use different statistical principles to find all this. But yeah, so that's my thought process of creating these columns. Okay, so that's what I've been doing. So I've just checked the distribution of parent versus the number of children they're in. Parent versus if he's a parent or not, and the number of children if he's a parent is if he's sorry, the number of children he's having if he's a parent or no. Okay, and yep. So what I'm so there's a logic here. Just hear me out. So if you're a parent and you have more than one child, then yeah, doesn't make there's nothing to infer that you are a parent. Let's say you're a parent and if you have zero children, so I feel you are an expecting parent, meaning you're expecting to have a baby in the future. I mean, coming future. And if you're not a parent and if you have a child, then that means you're a guardian. If you're not a parent and you do not have a child, you're neither parent nor guardian. Basically, you're a free man. From so, I mean, you're not free man. I'm just kidding. Trying to bring in slight humor here. Yeah, so that's what I have inferred here and created a column out of it. So again, being a parent or not can also matter matter on your productivity, because at the end of the day you have to support a lot of people and try to bring in I mean, try to work harder, right? So that's the main reason I thought about this and brought in more stuff there. Yeah, and yeah, let's go ahead. So now what I'll be doing is I'll be doing feature selection. Now, there are a lot of columns. I don't want these many columns in my data for you. So I mean, since it results in cursive dimensionality, that's why I'll be dropping few. So how do you drop? There are many ways to do that. I have used something called variance inflation factor, and I've used it only on the numerical columns. So if variance inflation factor is greater than 5, then that particular column will be dropped and it will do a second iteration. So that's what this while loop does. So if you see here for this particular column, it is 23, it's dropped, and then the VIF parameters, the VIF values reduced drastically. So this is the column that I had to drop. Then I also did the heat map to check the correlation. I could have dropped to one more column. So I mean that's the improvement that I have to do. So the inflation factor talks about multicollinearity, which basically talks about the correlation between curves. So it is always not good to have to two columns which are highly correlated. It's better to drop one. So yep, this is another place where I could have improved. I could have let's say I could have dropped few more columns. Actually, that's something I need to look into later. And then what I had done next is, as you all know, computer does not accept string values. I mean, the model cannot learn anything from string values. It basically needs numbers, right? For that purpose, I'm encoding on a categorical column. So there are different ways to encode. Also, there's label encoder, ordinal encoding, autoencoder, and then target encoding, etc. So I've used periodic dummies and I've encoded here. So if, for example, like let's say work from home setup available is yes for a particular record and no for a particular record. If it is yes, then it will add one to that particular record, and if it is no, it will add one for that particular record. But I've done drop first is equal to two because if it is yes and if it is added one, then it is obvious that for no it should be zero, right? So that's the reason. So I've dropped that particular column. So let's go ahead. I just plotted the distribution of the predictor variable. That's the support. Just see the distribution here. So if you see career is the highest here, it is not a balanced distribution. So it will be good if we balance it out. So that's something I can look further in my next iteration. So maybe bringing in smart or something to generate synthetic data and make it balanced. That also I could do in the coming future. Now I'll be dividing the data into train and test, so that I can train the model with my train data and test it with the test data. I'm going with the ratio of 70-30, wherein 70% is my training data and 30% is my testing data. And now we have come to the final phase, that is the model building. So I've used logistic regression as my first model because that's the first model I learned for classification. And I won't be speaking about what is logistic regression because I've built many models and explaining each and every one of them is time consuming. So I'll just quickly talk about what I've done here. So I've trained my logistic regression model here and plotted its confusion matrix, and I've taken the classification report. I'm just focusing on F1 score because I'm neither leaning towards the precision or recall. I want a balanced score which is leaning neither towards the positive side or the negative side. And moreover, this is a multi-class classification, so I don't. I prefer it to be F1 score than any other scores. Then I've used k-fold cross validation here to check the average F1 score for different folds, and this particular model gave me a score of 50% of that, which is 0.50. Then I've used naive bias, and I did the same thing. I trained the model, checked the confusion matrix and classification report, and then my F1 score is 51%. Then I used k nearest neighbors, and for k nearest neighbors, it is since it's an algorithm which sees its nearest neighbors, right? Depending on its distance, so it's always better to scale the data. So scaling the data is needed because sometimes there can be changes in the units and the scale at which the two columns might be on a totally different level. So for that, I want to bring everything into the same page. That's why I'm going to scale the data. For scaling the data, there are two ways. One is standard scaler and one is min max scaler, right? I've used both here. Right now, I'm using standard scaler. So I've scaled the data and then I've done an iteration. I mean, if you see here, I've done here the k nearest neighbors classifier. This is the base model. I've not included any parameters, and I've done put a for loop and checked for different values of k how it performs. So if you see here for if k is the n neighbors, I mean not k, nearest neighbors actually. Sorry for that. If the nearest neighbors is equal to 90, then I have a score of 55. Right, 0.55, that's 55%, right? So I have done that here, and then checked it. Then I've done with min max scalar as well. So the same thing happens here, and For that, I got the nearest news to be 37 and the score to be 0.58. Post that, I tried a decision tree, and for that, I had an average of 0.52. I mean, and in the K-fold one, I got 0.51. Then we did random forest. Here you see a very significant jump, that is 0.62. Then I did ADA boost. Again, there's no change here. I've trained the model, checked the confusion matrix, checked the classification report. I'll do a cross validation and then get my score. So I've got here 53%. I've multiplied by 100 here. And similarly, I've done gradient boost and I've got around 64%. Now I've done hyperparameter tuning for the two best performing model, that is random forest and gradient boost. So hyperparameter, I've used randomized search CV, and I've iterated to different parameters and different values for different parameters, and I've gotten the best parameters and I've fit that model and trained it, and then got the scores for it. And same thing I've done for the gradient boosting as well. So yeah, this after this I did stacking. I stacked my gradient boost algorithm with my random forest algorithm, and I've checked how the model does. So yeah, this basically includes the this basically concludes the presentation. So there are a lot of things I could improve. I could do a better job at feature engineering and feature selection. I could do better job at improving my model. I could have used dimensional reduction techniques such as PCA or UMAP, or I could also improve. Could have also improved the model. I could have made the code much more robust. I could have tried the object-oriented program. I could have used asynchronous. I mean, object-oriented program wouldn't have improved my algorithms, but it would have the coding practices would have been good, and I could have also used asynchronous function to make my to get faster results from my LLM function. I mean API call, and there could have been a lot other improvements done. So that's the main reason I always strive for this. So I wrote this code just to improve myself, and I'm trying for this master's program also to improve myself in computer science and make myself better there. So yeah, this is, but basically this is the first cut of whatever I've done, and it is not very great, but I can make it like leap better by leaps and bounds, because I mean I was short on time, so I've just done very very basic, but this can be improved a lot and made much better. So post this, I mean, after all the improvements that I've done, what I'm planning to do is I'm going to create a deployment pipeline wherein I deploy the model, and then I can create an app from which people can enter their data and then send it to the model, and get results in real time. So that's what I'm hoping for. But my main focus right now is to improve the model and make it much better. Anyways, if you, I will add this notebook to my GitHub repo, and we'll share it in the Word file as well. So this video will be uploaded onto YouTube, and yeah, thank you all, thank you for providing me this chance.